Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been looking at algebraic equations and linear relations, finding the patterns, finding the algebra in those patterns, graphing them. Now, what we started out with at the start of this unit is we'd start with a pattern like a tables and chairs pattern or a diagram and circles pattern or Mr. Bones pizza. How much does it cost if you add 5 toppings to the pizza? We'd look at patterns like that. And then we'd generate a table of values, and then we'd find an equation and an expression, and we'd graph it. Now, what we're going to do now is we're going to start a little more abstract. We're going to start with the equation and then use the equation to get data to make a graph. So the first question I have here is use the linear equation y equals negative 3x plus 4 to complete the following steps. Make a table of values, use positive and negative integers and 0 for the values of x. Make 5 ordered pairs. So what we're going to do is we're going to make a table of values. Okay, so there's a table. Now we don't know what this is the graph of. It's more of an abstract situation, so we'll just call the left-hand column x, the right-hand column y. And this says use positive and negative integers and 0 for the values of x. So we get to choose the values we use. Now let's keep it simple. They have to be positive, they have to be negative, and we have to use 0. And we have to have 5 of them. So why not do this? We'll say, okay, for our negative values, we can do negative 2 and negative 1. We'll use 0, we'll use 1, and we'll use 2. And then that satisfies all the criteria of the question. Now, how do we get our y values? Well, we do what we were doing the day before. We take our math equation that was given, and we're going to solve it by substitution, and that will give us our y values. And then hopefully we'll find a pattern. So the equation is y equals negative 3x plus 4. I'm going to start off by substituting in negative 2. So I'll do y equals negative 3 times negative 2 plus 4. Y equals negative 3 times negative 2 is 6. Plus 4. Y equals 10. So when x is negative 2, y is 10. Okay, and I'll do this again. We'll do it all again. Do it all. So y equals negative 3x plus 4. And this time I'm going to substitute in negative 1 for x. So y equals negative 3 times negative 1 plus 4. Y equals 3 plus 4. Y equals 7. So when x is negative 1, y is 7. And you'll notice we dropped by 3. We'll want to see if that continues. So we'll do one more. Y equals negative 3x plus 4, y equals negative 3, and this time we'll substitute in 0. Negative 3 times 0 plus 4, y equals 0 plus 4, y equals 4. So when x is 0, y is 4, and you can see we decreased by 3 again. So this pattern is going to be consistent. So we can just use the pattern to get the next two. When x is 1, y will be 1. And when x is 2, y will be negative 2 if we're continually going down by 3. So that's how we use the equation and some values for x to get some values for y. Now those aren't the only values. Let's jump ahead here. And in letter B, it says determine the value for y in the ordered pair 11y by using substitution. So there are numerous values we could get for y using this equation. So if I use that same equation, y equals negative 3x plus 4, and this time if I'm given that the x value is 11, let's see what our y equals. So we'll use substitution. Y equals negative 3 times 11 plus 4. Y equals negative 3 times 11 is negative 33 plus 4. Y equals negative 29. So there's another point there. When x is 11, y would be negative 29. So there are numerous points we could get for this graph. Now, letter C says graph the ordered pairs from the table of values. So let's make the ordered pairs. So the first ordered pair was negative 2, 10. I'll just make sure I'm grabbing these right from the table. Then it was negative 1, 7. Then it was 0, 4. Then it was 1, 1. And then it was 2, negative 2. And we also have the point that we just found, 11, negative 29, right? So, we'll just do one more double check there. Okay, everything looks good. Everything looks good there. Now, let's graph this on the coordinate plane. So we have our x-axis, we have our y-axis, and where they cross right here, this point where they cross is called the origin. And my x values are going up by 1 every time, so I think it's reasonable to do that on the x-axis. So I'll go, here will be 0, and then 1, 2, 3, 4, 5, 6, 7. And then going negative, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So there's our x-axis. It doesn't have a name because this is a pretty abstract graph. We're not finding the graph of anything in particular. Now let's look at our y values. Our y values go down by 3, so they're either increasing or decreasing by 3. So I think to make this reasonable, what I'll do is I'll say, okay, right here would be 1, and this would be 2. So I'll go up by 2s. So every single line would be 1. So there's 2, 4, 6, 8, 10. And I think that's as far as we have to go up on the y-axis, but I'll go up to 12. And then I'll put some negative values for the y-axis as well. We still have to keep that same scale. So right here would be negative 1. This will be negative 2, negative 4, negative 6. I think that's as far as we have to go down on the y-axis. Okay, let's plot our points. Now the first point was negative 2, 10. So that means we go across negative 2, up 10. We'll put a point right there. Okay, we'll call that negative 2, 10. Now our next point is negative 1, 7. So that means we'll start at the origin, we'll go left negative 1, up 7, which is right there. So I'll put a point right there, and I'll call that negative 1, 7. Now our next point is 0, 4. So we're going to start on the x-axis. We're not going to move anywhere, but we're going to up to 4. We'll put the point right there on the y-axis. That's 0, 4. Okay. Now the next point is 1, 1. So we're going to go to the right 1 and then up 1 on the y-axis. 1, 1 will be right there. And then the last point is 2, negative 2. So we'll go across 2 and down negative 2 right there. And I realized I didn't label a couple of these points, so I better go back and label them. This was 1, 1. and this was 2, -2. Now take a look. We should be getting a straight line, a linear relation. And there can be data anywhere on this line, so we join it up. That's no good, I'll try again. That's no good, I'll try again. It's hard to do. If you don't have a ruler, and I don't have a ruler. There we go. And I put arrows on the end to indicate that this graph could go on forever in either direction, right? In fact, we found a point 11, -21, -29, right? When that point would end up like somewhere, down here, right? 11, -29 would be like somewhere down almost off the page. So there's our graph. The last thing we want to do is write the equation for this on the graph. So we'll write y equals -3x plus 4. And that's a linear relation because it's a straight line. Okay, I hope that helps. I'm going to do one more video where we do another graph. That's all for now. Flexing Teacher Weber out.